Hello, everybody. Today we're going to look at equilateral triangles, which we all know have three equal sides. So something I want you to think about is an equilateral triangle also an isosceles triangle. Now, an isosceles triangle has two equal sides. So let's think about that. If an equilateral triangle has three equal sides, does it also mean it has two equal sides? Why, yes, it does. So an equilateral triangle is always an isosceles triangle. And sometimes isosceles triangles are equilateral triangles. That's kind of like the square rectangle deal, right? Okay, so today we're going to talk about the angles of an equilateral triangle. And so I did my very best to make a perfectly perfect equilateral triangle. It's not quite perfect, but we're going to just go with the fact that it's pretty darn close. Okay, so what do we know about the angles of all triangles? The three angles. We know that they add up to what? 180 degrees, right? So they're always going to be 180 degrees. Now, if an equilateral triangle has three equal sides, what do you think that says about the angles of an equilateral triangle? Yes, they are also the same. So if we know that they have to equal 180 degrees, how would we figure out what just one of them equals? Well, we'd have to take that 180 degrees and divide it by how many angles? 3. So what is 180 divided by 3? Well, 3 times 6 equals 18. So that would be 6 tens. And then we just have our 0 here, so we know it would be 60 because 60 times 3 is 180. So each angle is going to be 60 degrees. Now, I'm going to use this triangle to actually show you that all the angles are the same size. So no matter what I do here, if I fold this triangle in half, the two angles that meet are going to be the same size. So let's look at angles A and B here when we fold them together. Look at that, they're the same size, or almost perfect because my triangle's not perfect. So then let's go with B and C. Let's put B and C together and see if they're the same. Look at that. Oops, as I'm falling it, look at that. They are also the same measure. This is what we did with isosceles, right? Except for that it was just two of their angles. And here, the last one that we didn't do is A and C, right? So if we put those two together, once again, they're the same measure. So we can prove it by just actually drawing an equilateral triangle and folding those angles together. So if we have one drawn here, again, I just copied that one, so it's pretty darn close. If we know the measure of one angle, and we are told that that's an equilateral triangle, can we find the other two angles? Yeah, because they're always going to be what? 60. No matter what, if you have an equilateral triangle, it has to be 60 because they all have to be the same. And there are three angles, and we know they all add up to 180. So if you have an equilateral triangle, you know that they're always going to have 60-degree angles. Now that can help you solve other problems. Let's say you had, I don't know, we're going to make an isosceles triangle here or something. Well, gosh, that's not even a triangle. But let's just pretend. If you know that this part of this triangle is an equilateral triangle, you can use that to help you solve the rest of the triangle angles. Or if you have, so just keep that in mind, that if you know if someone tells you it's equilateral, no matter what, you're going to be able to use that information to know that they are 60-degree angles.